This is dilations and translation. So basically what happens is you have a function that was translated and it's also being dilated. Keep in mind on the exam, I will tell you, hey, these graphs here are dilated. You need to find the dilation. So the only times you need to find a dilation is if I tell you to find it. In this case, we are. So let's get started. Well, my parent function is y equals x squared. I always like to write my parent function. Then I like to note and observe, did it get translated and reflected or not? Well, in this case, no. It only got, this parent function here just went to the right by 2 and up 1. So I'm going to write the equation for my translation, which is y equals x minus 2. It went to the right, so it's a minus squared, and then plus 1. So the plus 1 goes on the outside. All right? Now I'm going to rewrite this equation and put my dilation variable because I want to solve the a value. I want to solve what is this number that's multiplying this graph here to make it what it looks like to be skinnier. That's making it look skinnier. It's changing its slope. We're trying to find this new slope. Okay? All right, same like before in every other video. I'm just going to pick a point. Looks like I like this point right there, which is my x value. I'll put it right over here. My actually I'll write it down below here. My x value is 3 and my y value looks to be 3. Alright, this is my x and this is my y. Alright, so I picked that point. So let's just go ahead and plug them in. So we're going to plug in 3 equals, we're trying to solve for a, and then my x value is 3, so we're going to get 3 minus 2 squared plus 1. Okay, first thing is what's 3 minus 2 inside our parentheses here? Well, that's just 1, so we're going to get 3 is equal to a. We're going to get 1a times 1 squared plus 1. Okay, what's 1 squared? 1 times 1 is 1. A times 1 is just 1. So if you look here, we're going to get a times 1 plus 1. 1 squared is just 1. A times 1 is just a. Anything times 1 is just that value. Alright, so I'm just going to rewrite this as a plus 1. Now how do we undo subtraction, addition? We just subtract 2 to both sides. So we're going to get a is equal to 2. Therefore, my new equation is going to be y equals, look up here, I'm plugging in my a value in for the a right there. So that's just going to be 2x minus 2 squared plus 1. And that is my new equation for this here. And you can even plot in points. Plug points in here and see if you get this value right there. So plug in 1 and see if your y value is 3, and you will see that that is the case. All right, let's move on to something more complicated. Let's look at a reflection. So my parent function is y is equal to the absolute value of x. Okay. It looks like it got reflected over the x-axis. It looks like it got reflected over the x-axis. It was shifted to the right one and went up 1, and then it looks like it kind of got a little bit skinnier. All right, but I don't know, maybe we'll just end up finding it out. So first thing I want to do is I want to write my reflected equation. Well, I know for a fact it got reflected over the x-axis. It looks like it got reflected over, and then it looks like it just went to the right by 2 and then up 1. So I'm going to go ahead and write my reflected equation. We'll put my negative on the outside because we're multiplying the output, so I want reflection over the x. Look at the previous videos if this confuses you. Then we went to the right, so I'm going to write my new equation. Okay, we're going to the right by 1, so x minus 1, close it. It's inside because it's our input, and then we go up by 1, so plus 1. All right, now I want to find my dilation. I want to find out what made this what looks like to be skinnier. It looks skinnier. So I'm going to go ahead and write that out. We're going to get y equals, ooh, I don't like that color on there. Let's change it to maybe this right here. We're going to get y equals, we're going to get negative a. We want to solve for the a value, x minus 1 plus 1. Okay? First thing I'm going to do is I'm going to pick a point. Let's choose when x is 2, my y value is negative 2. It's in the y direction. So when my x value is 2, my y value is negative 2. So I'm going to pick that point there. Okay, now I'm going to plug it in. So down below here, we're going to plug in negative 2 for y. We have negative a times, we're going to plug in 2 for x. So that's just 2 minus 1 plus 1. Okay, let's go ahead and simplify this. We're going to get negative 2 is equal to negative a times, what's 2 minus 1? Well, that's just 1. So we get the absolute value of 1 plus 1. What is the absolute value of 1? That's just 1. So it's just a times 1 plus 1. Well, what's negative a times 1? It's just negative a. So I finally can just leave it like such. Okay. What do we do to get rid of the addition? We subtract 1 of both sides. And we're going to get negative a is equal to negative 3. Let's bring it up here. We have negative 3 is equal to negative a. What do we do to get rid of the negative? Well, we divide by negative 1. And finally, we're going to get negatives cancel. Negative divided by negative is a positive. And we're just going to get 3. So this new equation here is we're going to just take our a value and plug it back in for this equation there. So we're just going to get y is equal to negative 3 x minus 1 x minus 1 plus 1. And this is my final equation. Okay, hopefully that helps. Why don't you go ahead and try doing these bottom two right here.